Welcome to today's lesson on exponential and logarithmic equations. We're going to be looking at topics covered under the standard 2.5b and also topics taught in the study island lesson exponential and logarithmic equations. And just remember, as you're going through this video, please be taking notes so you have those to refer back to in the study. And then also you can pause at the beginning of a question, work it out, and then watch how I do the question, and then maybe you can give yourself a gauge on how well you are getting this book. Mainly, the two things we're going to be looking at today is how to find the inverses of an exponential and logarithm equation, and then also how to solve those equations. That's what you have to look forward to today, and I am so glad that you're here, so we can go ahead and start taking some notes.
The first set of questions we're going to look at is how to calculate inverses between logarithmic and exponential functions. So the logarithm here has a base of 0.8, and that becomes the base of the exponential function. And then here it has an argument of x, and that becomes our exponent, and that's your inverse. And so the inverse here is going to be d, and that's your final answer. Here my base is 7.2, so that's going to become the base of my logarithm. And the exponent is x, so that's going to become the argument of my logarithm. And that's the inverse of the original function, so that makes my answer A. Here my base is e. So that's going to make my logarithm base e. And then my exponent is x, so that's going to make my argument x. But here, when I have a logarithm with a base of e, that's a special logarithm called the natural log that we show with the letters ln. So this is the same as ln x. So that's going to be the inverse of my original function, which is a. Now this function it wants us to find the inverse of has this plus 5. So because it has that plus 5, I have to go back to my original way that we talked about in the lesson function inverses, where you change the f of x to y and then switch the x's and the y's. So that means I'm going to have x equals 2 to the y plus 5, and I'm going to have to solve for y. So the first thing I'm going to do is subtract 5 from both sides. And I'm going to have x minus 5 equals 2 to the y power. And then we're going to go over more how to solve for exponents that are variables in the next couple of problems. But the first thing what I'm going to have to do here to get this y is I'm going to have to take both sides to the logarithm of a base 2. And I choose base 2 because the base in my exponent here is 2. So when I do that, I end up with the logarithm base 2 of x minus 5. And then on my left side here, the base 2 and the logarithm base 2 all cancel out, and I'm just left with a y. And now that I have y by itself, I have my inverse, so my answer here is going to be C. Now we're going to look more at how to solve functions using logarithms, and these are all the properties of logarithms that we can use. And so this is a picture that I took straight from your study island lesson, so you can go there to look these up at any point. But I'm going to be referencing these properties as we go through the different types of equations we're going to be solving. So here we're solving for the x, and the first thing we want to do is get that logarithm completely by itself. So I have this 2 out front that's being multiplied by it, so I'm going to divide both sides by 2. And those 2's will cancel, and 4 divided by 2 is 2. So I'm left with the logarithm base 3 of 4x equals 2. And so to eliminate the logarithm from the problem, If I look over here at my properties, number 4 says if the logarithm is in the exponent and the bases match, then I'm just left with the argument. So here I'm just left with n, and that's the one I'm going to be using to solve this. So that means I'm going to take and make both sides an exponent with a base of 3. So here when I do that, the log of 3 and the 3's all cancel out, and I'm just left with a 4x equals 3 squared. Well, 3 squared is 9. So 4x equals 9. I'm going to divide both sides by 4. And so then x just equals 9 over 4. And that's going to be my final answer, which is B. So this problem here is very similar, only I'm working with a natural log. So that means I'm going to see the letters ln here instead of log base e. And so I'm going to divide both sides by 6 to get that natural log by itself, which is the first step. So I'm going to have ln of 5x equals 4. And so since this is a natural log, it's a base e. So that means I'm going to make e the base on both sides, and my equation is going to become the exponent. That's going to cancel out, and I'm just left with 5x on the left side equals e to the 4th power. And I just continue solving. I'm going to divide both sides by 5, and I'm left with x equals e to the 4th over 5. And I just leave that e there. It represents a number just like pi does, but it's a very large number, so it's easier to just write the letter e. And so that makes my final answer A. In this problem, the logarithm is already completely by itself, and there's only one of them, so I'm just going to go ahead and make both sides an exponent with a base of 6, because the base in my original log here was also 6, and so that makes this all cancel out, and I'm just left with x plus 5 equals 6 cubed. Well, 6 cubed is going to be 216. And so then I just subtract 5 from both sides. 5's cancel, and I'm left with x equals 211, which is my final answer, B. Number 8 is a little bit different. I have 2 logarithms being added together, and they're natural logs here. I can't just raise each of these to the e. First, I'm going to have to make this one natural logarithm. And so to do that, I look over here at my properties, and I see that when I have 2 logarithms separated by addition, that's the same as one logarithm with the arguments being multiplied. So that means I can rewrite this side as out of the n with the argument of 5x minus 2 times x plus 2. And I need to do that step in order to continue solving and raise each of these with an exponent of base e. So that's going to be my next step, is to make each of these an exponent with that base e, and that's going to cancel out my natural logs. And so then I'm just left with 5x minus 2 times x plus 2 equals 5x squared plus 13. And so now I'm just going to solve for x. So the first thing I'm going to do is FOIL this out. 5x times x is 5x squared. And then 5x times 2 is a plus 10x. And then a minus 2 times x is a negative 2x. And then negative 2 times 2 is negative 4. And that's going to equal 5x squared plus 13. Then the next thing I'm going to do is combine like terms. So I'm going to combine like terms on the same side first. So I'm going to combine those x terms. 10x minus 2x is 8x. Minus 4 is 5x squared plus 13. And then I'm going to combine like terms on opposite sides. So I'm going to subtract 5x squared from both sides. and that actually causes them to cancel out on both sides. And I'm just left with 8x minus 4 equals 13, which is a pretty easy equation to solve at this point. So next I'm going to add 4 to both sides. And these 4's cancel, and I'm left with 8x equals 17. I'm going to divide 8 from both sides. These 8's cancel, and I'm left with x equals 17 over 8, which is letter C, and that's my final answer. Once again, before I can solve this, I'm going to need to combine these logs into one log. So just like before, I can take the log of 21, and then as my argument, I can combine those by putting them multiplied to each other. So it's going to look like this. And it still equals 1. So now to eliminate the log, I'm going to make everything an exponent with a base of 21. And these are going to cancel out. And I'm just left with x times x minus 4 on the left side equals to 21 to the first power. Well, here I'm going to have to distribute that. So it's x squared minus 4x, and 21 to the first power is just 21. Well, now it's a quadratic, so I'm going to have to get everything on one side and set it equal to 0. So I'm going to subtract 21 from both sides. On the left side, there's nothing to combine it with, no like terms, so I'm just going to have x squared minus 4x minus 21 equals 0. And so now you can use graphing, quadratic formula, completing the square, or any of those ways we know to solve quadratics to solve this. I'm going to use factoring. And this factors to x minus 7 and x plus 3. And so I'm going to have to set each of those equal to 0 to go ahead and continue solving this equation for x. And when I do that, I'm going to get x equals positive 7 and x equals negative 3. However, you can't get, when you're solving equations that have logarithms in them in the beginning, you can't get a negative number for an answer. So this is an erroneous answer. It's not a solution. It's not part of the domain. So that means my answer here is just x equals 7, which makes D my final answer. Okay, this problem here, it's the same deal. I want to eliminate this logarithm from the equation so I can continue solving. It has a base of x, so that means I'm going to make a base of x on both sides and make everything else an exponent, and that cancels these all out. I'm left with 1 over 256 on the left side equals x to the negative 4th power. Well, I don't like negative exponents when I'm solving, so remember that's going to be the same as 1 over x to the 4th. Now it's positive though, and then this is two fractions equal to each other, so I can cross multiply to solve. 1 times x to the 4th is x to the 4th, and 1 times 256 is 256. And now I just continue solving. I need to remove the 4th power. So the opposite of going to the 4th power is taking the 4th root. So I'm going to take the 4th root of both sides. That cancels out the exponents, and I'm just left with x. And taking the 4th root of 256 is 4. So that means my final answer here is going to be x equals 4, which is letter B. So this problem here has 2 logarithms in it, which makes it look complicated, but it's really not. It just means that we're going to repeat our process of solving twice. So this logarithm has a base of 3. So I'm going to raise everything to an exponent with a base of 3. And that cancels out the first logarithm, and I'm left with the logarithm of 3 with x equals 3 to the first power, which is just 3. And then I'm going to do it again. So I'm going to have an exponent, and everything in the problem is going to become an exponent with the base of 3, and that cancels out that logarithm. And I'm left with x equals 3 cubed, and 3 cubed is 27, so my final answer here is going to be B. Thank you for joining us today, and I hope you learned something new.